Okay, good afternoon, everyone. Thank you for joining the session. Thank you to our speakers as well who have joined. I think we'll wait for 4 to 5 minutes for a few more people to join and then start the session.
Hi everyone, thank you so much for joining PTC and Reddington along with Ramses company. Thank you. First, I want to thank Ramses company for all the support. So we will begin the session. We have Michael from PCC who will conduct throughout the session. Please, if you have any questions, post all your queries in the chat button, and the team will answer at the session. Over to you, Mr. Michael.
Thank you so much. I appreciate that introduction, and it's very nice to meet you all today. I'm Michael. I work with PTC, and I've been with Onshape for 6 years in various roles. But before that, I was a long time SolidWorks reseller for about 15 years before that. But I've also had some time working in the real world at manufacturing companies like yourselves. So there's a lot of experience that I'm going to bring into the presentation today. I'll explain the journey of why Onshape exists, what led it to become one of the first true software as a service type tools. And we're going to go through a demonstration of the Onshape platform today so you can get a feeling for how it works in a real life scenario. So I really am excited to show you this today, and can't wait to hear some questions later on. We'll leave some time at the end for questions. So without further ado, I will just go ahead and start up the presentation here. So Onshape is a true software as a service or cloud-based system for doing product development. And the people at Onshape are all essentially former engineers that used to work at other CAD companies. So you'll find people at Onshape that worked on Creo, that worked on SolidWorks. Many of us are from the world of SolidWorks. They're people from Autodesk, right? So this is not our first CAD system that we've ever built. And we wouldn't build a CAD system unless we actually needed to. It's hard work, but there are reasons why we thought we had to build a new CAD system, and I'll explain those here in the first part of the presentation before I jump into a demonstration. And so let's talk about some of the challenges that we've been hearing over and over again for the last 20 or 30 years in the world of product development. This is also true for schools. I understand there are universities and also in attendance. So there's definitely challenges there as well in student access to a high-end CAD system. dealing with the file management, working on any computer you want. So these are some other challenges that we've heard, but I'll dive in on this right now. Let us imagine, if you will, that we have these 4 engineers working on a design, okay? Now, these 4 engineers could be working in one factory, or they could be working all around the world, right? It's much more common now that we have a distributed workforce, correct? So let's think that we have these 4 people and they need to think about working fast. They need to work in a very innovative way. They want to build products that meet the market demand. And they also want to do it efficiently, right? They don't want to waste time on menial tasks like file management. But if you look at this dotted line going across the screen, anything below this dotted line will get in the way of that speed, innovation, and efficiency. So let's look at the actual software itself. You install a copy of a CAD system when you need to do product design. This copy of a CAD system, it takes some care and feeding. There's one update a year, typically, big update. You might also have service packs, 4 or 5 service packs that you deploy throughout the year. A lot of people won't even install the latest version of the CAD system. I'm not going to pick on any one vendor in particular, but almost all CAD software has a process that you have to manage to install the CAD software on powerful Windows-based PCs, right? That's really all they work on. Now, if you have a larger design team, sometimes you will have PDM software to manage the large amount of files that are going back and forth. You'll also install PDM servers, license code servers to manage all the different software assets that your company might have. You might need a VPN if you're working remotely, which of course, we all have that experience now in the last year. There's many different things you have to even think about. The viewers, how can people outside of the world of engineering view the CAD information? If you don't export a PDF, you ask people to install a viewer to view the SolidWorks, Creo, Inventor, whatever it might be, right? But to add insult to injury, there is a software version mismatch with all of these CAD systems. If, I'm just going to pick on SolidWorks a little bit because I know SolidWorks very well, and I worked for a reseller for 15 years. This was a big problem. Like if you had SolidWorks 2018 and you sent a file to somebody with SolidWorks 2020 and they save it, that person with SolidWorks 2018 cannot open that file again, right? So that seems like a really big problem, but nobody, complains that much about it. Well, I have heard complaints, actually, if I think about it in the past. It's just been so long that I've been working at Onshape, I've forgotten, I think. But that's a big problem. It hinders productivity, and what will people do? They'll end up exporting a neutral file, a step file, or something like that, right? So now, how do you actually share that file? That's the next question. Well, if you're working in an informal environment, you'll have, the ability to export, a file out of your CAD system and share it by email, share it by a flash drive, share it by cloud storage, Dropbox, etc., right? But every time you do that, you're creating a file copy, which begs the question, when you're working on projects together across these 4 people, you're asking, where is the latest version of that file? How do I know for sure that what I am working on is actually the right thing that I should be working on? Or am I even overwriting somebody's hard work, right? Now, if you're working in a company, you'll get more organized. You'll create a file system on your server, your Windows server, and store the files there. And you might create rules and procedures and get your IT department involved to manage rights and access, but it's still not perfect, right? So people end up buying PDM systems to help manage that. They put a database layer over the file system. But the dirty secret about the PDM systems out there are that they also create file copies, lots of file copies, in fact. So an IT department will have to start buying advanced, sophisticated servers and disk arrays. If you work across multiple sites, you'll have to dedicate bandwidth, to copying that information back and forth. I have many stories that I could tell, where this is actually the pain point right here of the file-based CAD system in a larger company. It's actually the PDM system because it requires so much feeding and care to keep going. And it also gets in the way of the engineer's job. You have these file checkout locking issues, right? People, when they open an assembly, they check it out of the PDM, it's locked. Nobody else can work on it. By the way, that's also true in a regular file server too. So really, this asks, you get the point here, right? These older tools that we designed kind of constrain the culture and the process. And because I have a couple extra minutes, I want to show you, essentially what I mean by that in detail. Let me go to this slide right here. So this is a drafting room back, really not that long ago, if you think about it, right? It's maybe the 1970s, early 1980s, right? I started on the drafting board myself. I was if you saw a picture of me, I've lost my hair a little bit. I've got some years on me. So I remember these days. And really, when companies went to digital transformation, when we went from the paper drafting board to computer-aided design, all we did was duplicate this entire process. If you look at this photo, you'll see every engineer on their workstation working on a copy of a drawing. And the copies of those drawings are stored in file cabinets. And you might have an administrator that maintains the record of who took it out and when. You have a manager that's assigning the work. But all we did when all these CAD systems were made, from AutoCAD to SolidWorks to Creo to all the other systems, it's really was just kind of duplicating that process. And if you look at it with this overlaid here, that's all we did, right? With CAD files, we created copies, put those copies on our CAD workstation, did our work in isolation, and then checked them back into the server. And then the database might have been monitoring it if you were lucky enough to have a PDM system to manage these things. Even if you think about moving your PDM system to the cloud, this does not solve the problem of working together in a faster, efficient way. Okay. So what Onshape did was develop a tool that allows for a truly concurrent design process where multiple people can work at the same time together on an assembly or even a part. That might be more rare, but very often you'll have engineers working on top level assemblies together in the world of Onshape, almost like you would if you're familiar with systems out there like Google Docs, Google Sheets, where you have that magical moment where you're in the same spreadsheet together making the changes in real time. That's what's happening in Onshape too. So it really is an interesting workflow that you won't see in other CAD systems. So Onshape, to do this concurrent design process, had to remove all of the files from the equation, meaning we're a true, proper database-driven application without files going back and forth at all. You have, of course, a CAD system, but the data management was built at the same exact time, where that's very different, right, than what you might be used to, right? You have a CAD system and you have Windows to manage your files. In this, the CAD and the data management are one and the same. Okay. So of course, we know how to build a CAD system. You're obviously going to be able to create all your parts, assemblies, and drawings. You can configure these designs. We provide libraries of information, like for hardware, bolts, nuts, screws. We have this very unique multi-part part studio approach, which I'll show you in the demonstration. And of course, there's, in industry specific items as well, like sheet metal, right? But the data management is really the key differentiator here. The CAD will look and feel very familiar when you see this, but this is what's different, the file management. And I should really remove that word from my vocabulary, the word file, because there are no files. Everything you do in Onshape is a managed database transaction. You can name these versions along the way. You can even create ideas called branches and iterate on those ideas and even merge them into your main timeline and restore these designs at any point. But you also see in this presentation communication tools that are really much more modern than what you might be, that you might be used to with other systems. So you're sharing information to the database when you're working with other people. You can see other people working with you in the design, and I'll make sure to show you this in the live demonstration. You can also assign work to people. So you'll see me sign in as several different users in today's demonstration. I'll sign in as Mike, the manager, and I'll assign the work to Debbie, the designer, or Ed, the engineer, or Mandy in manufacturing, right? So it's a user-driven system, right? Yeah, you're going to work with people, not files, right? All of this is very secure, by the way. If you think about security of a single file versus security of a very high-end data center driven application, Onshape has security similar to, if not greater than, your bank, right? It's very high-end security. We actually run on AWS, which is one of the world leaders in web kind of data stacks, where people store applications. So it's a very secure system. We have all sorts of different certifications, and we've worked with various companies around the world going through security checks, and it's happening all the time. But we happen to run on AWS. We have customers that are competitors of AWS, and they trust our security. So that should put to bed any discussion about security, but I will touch on this several times during the demonstration today. This information can all be, it's all available, as far as what is going on around the world. So as a manager, you might be able to, look at where documents are being opened from and who is taking the shortest amount of time to do their design work and give them a raise, right? You would actually be able to see this information, charts and graphs and metrics to make better business decisions. And this is something that no other CAD system that I can think of provides. This is actually more similar to what other software as a service tools provide, though. If you think about systems like customer relationship management, like Salesforce.com, things like that, you expect to have reporting and information about your business. Why should engineering be any different, right? So we'll show you that today. Everything goes through a workflow in Onshape. We'll show this live. So that's the quote unquote PDM aspect, of the Onshape system, where you can have items going through workflows with sign off and approval. And all of this is very easy to administer. So let me just hop out of the slideshow here, and we're going to build a product. Okay. Go back over here. There we are. So this is the product I'm going to build. It's morning time for me, right? So I'm having my morning coffee. And this is actually a coffee grinder that I use every morning to drink my coffee. And I'm going to build this, and there's going to be several different users that I might sign in as during today's demonstration. Okay, so it's when you use Onshape, you should think about it as a team-based tool. Even if you're a single designer, you're going to be working with other people at some point, unless you're completely building your own products and using your own products. I'm sure you have customers I'm sure you have supply chain partners that make, and fabricate your designs, right? So there's always more than one person, I would hazard to say. So let's actually go right through the demonstration. So this is all, a very interesting point. The first point that I make in my demonstration is that Onshape runs on any device, any modern device, I should say. I mean, it's not going to run on old computers, but anything in the last 5 or 6 years, it should be fine to run on. I'm running on a Mac computer, as you can see. You can run this on a Chromebook, which is obviously very popular in the institutional settings now in universities. Same with the MacBook, I would hazard to say. But this will work on Windows, of course. It'll run on Linux. It'll run on your phone. I have my phone right here, and here's Onshape on my phone. I just got to look at my phone for it to log in. There we are. And I can actually browse right in to these particular documents. So I'm going to go into this pulse oximeter document right here, and then jump in to a different tab of the design. I can see my project here and different drawings and renderings, right? And here is a what we call a part studio, and there's all my features, right? So that's Onshape on my phone, and I'll show you how that works. But here's Onshape on my browser as well. I'm just using Chrome. It'll work on any modern browser. Anything except Internet Explorer. You use something else. Edge will work, Firefox, Safari, whatever you want, just not Internet Explorer. It's just kind of old. So this is what Onshape looks like on the browser. That's the same model. You can see I have Ed, the engineer, on his phone in the document with me. I'll explain what that all means in a minute. An Onshape document can be built of multiple tabs, right? Assemblies, part studios, we call them, and drawings, as well as other, maybe rendered images, right? So I can just go right to that tab and see a rendering that I did with our rendering app. Of course, you're going to be able to create, detailed drawings of these components. Here's a sophisticated plastic injection molded component. And, here's the assembly modeling where you have your, you build in your, your animation, your mates, your bill of materials is also here. So I can look at, the mechanical BOM here, or the purchasing BOM, which gives different information, about the design. So let's actually build something fresh like that coffee grinder, like I mentioned earlier. All right, there we are. So I've signed in as Mike, the manager. When you create an Onshape company, or an organization, you're creating it as a company in Onshapes, right? So you create an enterprise or a professional company. You invite the users who should be members of that company, teams of users, right? So it's very, very easy to deploy this across your organization or even external. I have a document here that I'm going to work on. Of course, you can create folders for your libraries and things. So that should be quite familiar. But here is my the beginning of the coffee grinder design, and I'll go to my tab tool here so I can see a photo that I've uploaded to this. So here's a photo of my kitchen counter. There's my coffee grinder. So you can store anything, PDFs, movies, whatever you want in an Onshape document. Now here's the part studio where I'm starting to do my conceptual product design for this. And you'll see a very familiar kind of environment here. We have, variables for equations, features, sketches. This should almost look like SolidWorks, right? Parametric sketches, make your changes, right? Very quick and easy to understand the modeling aspect of this, because it's truly modeled. Even the icons kind of look the same, don't they? If you look at it and zoom in. So, this should not take a long time to understand how to draw things, because it's the same way you would draw things in other systems, right? Here's a loft with, all the end conditions that you would expect to see, right? And we can show curvature and all that. Solid and surface modeling in one tool. So I'll explain what that means later on. So let's actually go in and start working. I'm going to add a couple of fillet radii. We'll call it a 1-inch fillet radius over here. And that adds another feature to my tree right here. And now I want to get the design input of my product design colleague. Her name is Debbie. So I'm going to add a comment to this, and it opens up this comment window. And I can start typing in my colleague's name and say, we need help on the style. Oh, gotta get my keyboard to work a little better there. All right, here we are. Need help. Interesting. My keyboard has malfunctioned, so I will turn that off and use my other keyboard. One moment, please. All right, well, I'll just not type anything in right now. So I'm going to just add that comment, and I'm going to say share with Debbie. So now Debbie has been shared into the design. Okay. And I will go into another window as Debbie, the designer. And I'll just split my windows in half here so you can see the two windows, one next to the other, just to make it easier. There we are. So Debbie, if she goes to the shared with me, will see the same coffee grinder. You can see the same document name, and you can see a little photo of Michael now in Debbie's window. And she's view only in this design. So she was shared in automatically because I added a comment labeling this surface right here. And Debbie can, of course, see that same comment right over here, right? And she can select that surface. And now we're looking at the surface, and she could reply, yes, right? So she would be able to go in and work on this if she had permission. She doesn't yet. We can also do this thing called the follow mode, which allows us to share one another's windows. So I can double click on Michael's face here. And now if Michael rotates the model on his screen, Debbie will see the same point of view. So it's very nice to be able to work together no matter where you are in the world. You'll be able to have a design review session. Debbie might say, the fillet is too large. There we are. And Mike would see that comment come through, of course, in the replies. And Mike could actually make that change to change that to something smaller, right? But look what happened. Debbie sees that instantly, right? You didn't see me hit the save button or save check-in, save as. It's not asking me for that, is it? Onshape is recording a transaction for everything we do in the system. So if we look at this history view, that's when I first started my work today, this morning here in Boston time, 7:25 a.m. And then if we scroll up here, we can see all the changes that I've made. So every single edit is saved in Onshape, even though there is no save button. And we'll be able to create labeled versions in this timeline. So I can actually put a line in the ground here saying that, we're at version 1 of the design, and that's kind of where we are. And we can even explore different branches from any version. So this actually means that you'll never lose work again. I mean, CAD systems don't crash all the time, but when they do, it's a painful thing because not only have you lost the time, and you're interrupted, but you've probably lost your data. You might not save every single change, even if you have auto backup turned on. It's still a lot of stuff that you have to manage. Here, we can see every single change. You're never going to lose work again because every change is saved. So let's continue with the design process. I want to upgrade Debbie's permissions right here. So I hit the share button And Debbie has view and comment permissions right now. But I could increase her permissions to edit, and I will give her edit and comment. I do not want Debbie to share it with anybody else, nor I don't want her to have the export permission. So this is also something new, right? The ability to control the sharing of data in a much more fine way, right? If you gave Debbie a file, in a regular CAD system, Debbie could do whatever she wanted to do with that. Okay. And that's, I mean, that's just the way it works, right? You can have a file, you can do something. You can make a copy, you can make changes, you can share it with somebody else. With Onshape, you're able to set exactly the level of permissions you want. You can change them on demand, right? So the horse is never out of the barn. So now, if I, refreshed Debbie's browser over here on her side, we're actually going to see her permissions be upgraded because now she has all the tools to make changes herself, right? And she did not before. We can also create branches from versions. So I'm going to call this the design for manufacturability branch, and I'm going to create another branch for the style. There we are. So these are two work branches, two different ideas that we want to work on independently now. So Mike is going to work on design for manufacturability, where Debbie is going to work on the style branch. And how would you do this in other CAD systems? Well, you would probably do file, save as copy, or pack and go. You'd make more file copies if you want to try out different ideas. And with those file copies, you'll probably end up abandoning some of these files because there's no way of taking these changes and putting them back into the main design. You would end up either, just redoing those changes on the master design, right? So these things in Onshape allow you to try out different design alternatives very quickly. We also have the ability to configure designs, which is another topic, which I'll get into later. All right. So Debbie is going to work on the style. So I'll make her window the bigger window here. And I'm going to hide those planes. We have keyboard shortcuts, of course. And Debbie has a sketch right here on the side of a spline that she had here earlier. So, of course, we have proper style-driven surfacing and solid modeling in Onshape. That's the curvature plot right there on that edge. And I can use that to split a curve, all the way around our part here. So I'm going to take that sketch right here and apply them to all the faces around the part, right? So you can see I have that nice 3D curve now matching the surface. And I also want to pop that surface out by a small amount. So you notice I'm just typing in a few keystrokes to find the command that I'm looking for. I was asking it for the move face command. And now I just told it to pop this out by, I'm in Boston, so I'm using inches, by 1/4 of an inch, or I could tell to, be set to this wall thickness variable ×2, so you can do all your math and equations right here. So that's very quick and easy to add. This whole time in the timeline view, we're working now in the style branch, right? And I can even label versions in here. I could say, okay, we're at B2.1. Right. So that's a nice way of working. She could continue to do her work, maybe changing this fillet radius to something more stylish. So this is advanced surface modeling techniques now that I'm getting into. I'm not going to spend a lot of time drawing things because, as you can see, the workflow of how you make things as far as CAD modeling goes is similar to what you're probably used to, right? So that should be very easy to learn. All right, so now we've made that change. Now we're at, up here. We might even call that B2.2, if you really want to be formal. But this is just informal version management. We haven't gotten into releasing things with a revision. We'll get there later. Mike is going to work on the design for manufacturability. He's on that branch. That's why he does not see what Debbie has worked on. So Mike is going to take this surface model that he got from Rhino, essentially. So he's going to show the surface that he imported earlier. Of course, Onshape could make this, by itself, but many people use other sophisticated kind of surface modeling tools, and they want to import that data into Onshape and use it. So we fully support importing any kind of CAD type pretty much into Onshape. In this case, it's just a surface model. And I'm going to use that surface to replace this flat surface here at the top with the stylish surface over here, right? And I'll just hide that surface with a keyboard shortcut. And I'm going to split this into two physical components, right? So now we have two parts. You can see I have this parts list at the bottom. So Onshape is keeping track of all the part bodies. I'll rename this one to the base right here. And I'll rename this one to the cover. And I might even change the appearance of that so it looks a little nicer. I don't know what material this is made of yet. So what I'm going to do is bring up this part mass table where I can see both of my parts here together. Right now, this is a pretty heavy coffee grinder, 11 pounds. They're both parts made of aluminum right now. So I'm going to change that cover to some kind of plastic material. So I will edit that material. And we'll set that to be, I think acrylic might be a good choice. There we are. And of course, that will adjust the weight, of that assembly. We'll obviously hollow this out too. We'll get there in just a few minutes. I'm gonna, remove the top right here, and of course, you'll see the mass updating. There's not enough to see there. So now we have these two branches, right? We have this design for manufacturing branch, and then the style branch Debbie was working on. We can compare one on top of the other to see the differences between our two different thought processes. All right, so one right on top of the other. I can do a slider here to show what the differences are. And I can see that this fillet is incompatible with what Mike has done on his design for manufacturing branch. I can see, where all the changes have happened. And we can understand those changes. Now, furthermore, in Onshape, we can actually merge those changes. And this was all inspired by the way software development works nowadays. Like there's tools like GitHub, where you work on software code on design branches. So we were inspired by that, and that's how we built our Onshape management system. We can merge, we can pull the changes from the style into the main branch here, and I can pull the changes from the design for manufacturing branch into here as well. And it's merging the trees together. In fact, I'm going to call that version 2 where we are at this very moment now, just to have a nice moment in time here. But you can see the merge operations are here in the timeline. We have the best of both worlds. The cover now matches the crazy fillet that we had Debbie work on. And this is fearless design, right? We never have to worry about breaking the model. If the model did break on that merge, it could happen, right? Because, whatever the changes that happened might not have been something that could be merged, right? It might be geometrically impossible. So if that happens, you would be warned in the tree right here. It would show you the error. And if it really was a bad idea to merge these things, you could always just revert back to a previous moment in time, right? And it could be any moment. It could be like way back here, even on a version that I didn't work with. And I don't mind doing this because I can always just restore back at any time. So you have the full history at your fingertips with Onshape. There's just no way you would do this in any other system, because you wouldn't be saving every single file, every single change, and managing that. That would be impossible to manage yourself, even with a PDM system. So here everything is recorded, every single minute change, and it does not make the model bigger. It's a database transaction. That's really the thing I want to stress here. And you can, we teach this in our learning, center at Onshape, how to best approach design using this branch-based method. I just did a small shell operation here to hollow out both parts at the same time. Also, something a lot of CAD systems won't let you do is create one feature that affects two physical parts. And by the way, these are separate parts. It's not just a multi-body model. It's a multi-part model. This base could be used in any other design right now. And I don't have to do a file save as. It's just in the database. There's no C:/, right, that you have to worry about. I think we're at a point now where we can get our mold supplier involved because we have this plastic part on the top, right? And this plastic part needs to be manufactured. So of course we need a detailed drawing of that cover, and I'll stick it on a 4-view drawing. And I will create a few different views here. Let's do maybe a section view, through this area right here. That looks good to me. And I will make this a shaded view. You can see the title block is already up to date with all of the information that you would expect to see. I'll apply a couple of critical dimensions for this to be manufactured with tolerances. We'll call that plus 60 minus 0. And I'll move this out of here. But of course, we have all the different units and templates. I could, set this to a metric template, of course, maybe show the dual dimensions, right? So it's a proper, detailed drafting module that we have here inside of the system. So I like the way this looks so far. I'm going to release this. So what a release is a special version. If I look at my timeline view, I'm on this main timeline in this kind of open work in progress. But when you're ready to make something approved, you don't want it to change much anymore. You release it. A lot of people buy PDM systems extra for this, right? But here's the cover and the cover drawing. Even though I modeled that together with the base, I can still release the cover and the cover drawing independently. I can establish an automatic part number. So I just pulled that out of the air, didn't I? Well, I just told Onshape to go fetch one for me, right? So there's that. I'll give it a drawing number. Sometimes I like doing this. I like to just overwrite the suffix so it's the same. And another thing I like to do is name this release as an engineering change order or change request, right? Or notice or whatever you want to call it. So I'm releasing these to revision A. I need people to approve this. I want Ed, the engineer, to have approval rights. I want to let Debbie know that this is happening. And I'm also going to let my mold supplier know that this is happening. I work with them quite closely. And the mold supplier is not a member of my company. They're a guest. So you can very easily let people know what's happening, even if they're outside of your organization. And I will submit that for approval. Let me just make sure it's shared with all the right people first. I want to share to the engineering team that this is happening, view only and comment. And I could also let my manufacturing team see it as well. Maybe I'll give them view and export. All right. So now all the right parties have the right information. And I'll hover over here. I'm going to go to the phone. So this phone is Ed's phone. And you can see there's the change order that came in. And now Ed could actually click on that. And he's view only. He's going to be able to look at that drawing. There it is. There's the drawing on my phone. I'm just pinching the zoom, right, on my phone. He can look at that and then decide if he's comfortable approving that. He can see there's a pending change that he has to approve, right? So he can go to the release package, add his release notes, and then hit the release button. And as soon as Ed hits the release button, mind you, he's doing this from his phone. Now I can see that it's released. We're getting notification messages that it is indeed released. If I click into this ECO over here, we'll actually see his signature, on the drawing already there. So that's all set, right? And we could even have a rev block updating with rows and stuff. It's very easy. So that is a released cover, and the mold design person would have the ability to export this. This is a drawing, so you're only getting 2D formats, but he has access to the document in general. So he could export the cover like that and download it. Or maybe me as Mike, the manager, I only want him to have a step file. So I could email him a link to this file. So that's another way of doing this. If you didn't want to share the whole document, you can just share the cover. So I'll share a cover as a step file and include a message. It could have an expiration date and a password as well, which is kind of a nice security mechanism. So even if you want to use the older method of kind of sharing by email, that's even better with Onshape too, because you're emailing direct from the system and it's not going to create an intermediary file in your Outlook or email app. All right, so I'm going to go back to the main workspace where we do work, and we're going to put the assembly together. So right now we have a part studio of 2 parts. But we really need to put this together in an assembly with a motor and other, parts that make this coffee grinder go and, to actually work. So I have this coffee grinder assembly waiting for me, and I don't have any parts yet. I have a couple of blank labels, but I want to insert the base that I'm still working on. I haven't finished it, but I want to insert the released cover. So that triangle tells me that that's the released cover. I'm also going to insert another assembly called the blade. So I'm not going to browse through my system to find it. I'm just going to search for it. And there it is. There's a blade. There's a released one. And I'll do one more part. I'm going to search for a motor. Maybe I have a lot of motors, so I'm going to search for a supplier motor. So I'm searching my system for, a certain supplier, Bueller Motor Company. And I'll do a search for that. There it is. And these are, models that I've imported into my own library. These aren't like models that we're providing or anything. It's, just to be clear, it's stuff that I've added to my system. And I'll hide this cover for a moment so you can see that the parts I've added are in here. Of course, we need to put those in the position and mate them in the place. So I will move that blade out of the way. I'm going to fix this base, and I'm going to fix the motor where it is to the origin. And I'm going to group this and this together. That mates the cover and the base because they were designed together. That's all we need. I'll hide the cover. This motor has some motion already built into it. If I go into the motor in the tree, you can see there's a mate in here to let that spin, right? So that's easy enough. And I want to mate this blade to that right here. So in Onshape, it couldn't be easier. It's almost, it feels almost too easy. At first when you do it, but let's show it how it works. So I'm going to fasten the parts together. So I'm not going to use coincident or concentric or things like that, although you could. But here, I'm just going to say I want to find the center of this hole, and it wakes up that little mate symbol here. So these are automatically applied by the software. So think of them as like dynamic datum planes. And you see I can find the center of this shaft automatically, and it just snapped in, and it's fully mated. Right? And there was no predefined mates here. There was no tricks here up my sleeve. Everything is just, happening on the fly. it found the center of that D-shaped shaft and the center of that D-shaped hole. And now we have our mate in here, and it's one mate instead of 3 or even 4, because what I might want to do is just edit this mate and have this move up by a small amount. Well, not that direction. 0 in that direction. Z direction. There we are. That's better. So now it's mated just right there above the center. And that's what I wanted to have. So very, very quick and easy to add mates. And of course, you can do all sorts of mechanism development, with this. Now, this design right here, I might want to have different markets, right? For selling this to different countries, you might have different power requirements, different certifications. So we need to configure the design to address that, right? So I have 2 different styles with 2 different markets. I could have, many more markets, so the Saudi Arabia market. Yeah. And spell it right. There we are. So now we have all these 3 markets and variants, and we can configure the model to, have different power cables, different dimensional manuals, things like that, right? And we can also configure the size and shape of the part. So I'm going to do that as well. So I'm going to configure the base. But what I need to do, if I hide this cover, you see this motor is just floating in space right now. We need to make a shelf to attach it to this base. So we're going to edit this base in the context of the assembly. So now you can see it brings me back to the part editing environment, and it puts a shadow or a ghost, if you will, of the motor in its current position. And now I can just do my sketching, right? Create a plane, grab this edge. I'm not going to do a lot of CAD work, as I mentioned, but I have that. Now I can create a shelf, a rib or something, right, that attaches it to this part, normal to the plane, extending it outward, equaling the wall thickness. Just like that, you can see it's very easy to, create that feature. Of course, I need to do that twice to go in the other direction. So let's just do that. There's the rib. And I'll use that same sketch again. It puts an arrow next to it just to let you know you've done an in-context edit. But our in-context edits are much safer than what you might have seen in other CAD systems, because in Onshape, we have the full history of everything. So when we're doing the contextual edits like we're doing here, it remembers the moment in time in which I was doing that edit. So it's a much safer operation. You're not going to get, you don't have to break all of your references anymore. And one final thing I'll do here is just remove the motor from that right here. Oh, one other thing. I need holes, right, to drill through. So I'm just going to create a sketch here. I'll just grab these edges. I could either extrude them manually, or I could use our hole tool. So I'll say I want an ISO tapped hole M4 and M4 ½ mm pitch on this point and this point. Oh, M4, that's kind of big. Let's go smaller. M2. That should be better. All right, let's do that one. So now we're kind of set here, and then I can configure the design. We have the XR and the XS. We're going to have 2 different variants of the design, and I can configure, perhaps the material that it's made of. So I'll add a property for the material. The XS material. There we are. So the XS will be made of maybe stainless steel for a higher end coffee grinder. Of course, the name of the part has to change. Base XR. This is going to be base XS. Sorry. There we are. So you can configure these types of things. Even the part number could be configured. And I can assign the part numbers right from here. So it's very much like your business system stuff here that you're seeing. And I can configure the, maybe the wall thickness is going to be different between the two variants, right? So the excess can be made with a slightly thinner wall. So very easy to do that. And then back in my assembly, I can actually configure which base part I want to use now. And a lot of people would use, Excel or design tables or family tables to do this kind of stuff in other systems. But you can see it's database driven instead of file driven. So you're able to very quickly and easily, set these things up. And I'll even configure the labels, right? So I have these labels that I can configure in here as well. Non-modeled objects in the bill of materials. So here's the BOM right there. Parts list, bill of materials, and everything's here. And if I switch to the XR version, we'll see the XR base showing up in the bill of materials. Very, very easy. We'll turn our cover back on so we have the full thing. We'll do our final insert of the power cable that I have in my library. I can browse through, or I could just search for it. I usually just end up searching most of the time. Let's see which power cable. This one. So that's pretty much it. Of course, we need our drawing. I have a drawing waiting for me. I'll just refresh the view. Oh, yeah, there's my revision table. I need to fix my template here so that this locks to the right corner. I've been meaning to fix that. There we are. Very easy to do. Could show that. Oh, maybe you want to do exploded views and things like that. Of course, you could do that. And then I can release this at revision A right here, give it a part number for the drawing, and then release it just like the other stuff. So I'm not going to go through all that. But as you can see, the system allows you to kind of work in a different way. There are ways of, optimizing designs as well. Using different apps that we have in our app store. So, we have an app store which allows you to add different partner applications to your Onshape account. For example, here's OnScale. Here's 1IPM, Cadasio. This is a rendering app. We actually just bought this company, so that's just being included now with Onshape going forward. This is a simulation app that's true multi-physics simulation. So you could actually run simulation right inside the cloud and, taking Onshape data and running it through the OnScale system. So they're a close partner of Onshape. Tomorrow we have an event called Onshape Live, and we'll actually be announcing some cool stuff where Onshape has some stuff we're delivering natively in the, just in the assembly environment. You'll be able to do your stress analysis and frequency modal analysis, things like that. So that will be announced. All right, there. So what I'd like to do, we have about, half an hour left. I have many other things I could show you, but I would like to, perhaps open it up to questions, right? Because once people start seeing this, the gears start turning, everybody has questions. So, I can go in and show more things or answer questions, discuss the market in general. I can discuss the education market for Onshape as well, how people buy it. So I'll let you come up with questions. And while I'm waiting for questions to come through, Maureen, is there a, do we want people to type in questions, or do we want to, just have them unmute themselves? What is your preference?
So they can type in their questions, Michael.
Okay, great. So use the chat box we do have a large number of attendees, so I guess that would be the best way of doing it. So the chat box here in Zoom, you're able to just ask questions here. If you have questions on specific functionality, how the plans work, while I'm waiting for that, I'll bring up some interesting stats and information about Onshape here. I think I have a screenshot from yesterday. Here we are. This is the one. So, since so PTC acquired Onshape, we were our own independent company, last, in 2019, and they bought us in November 2019. We're both based in Boston. I'm in Boston. And PTC saw Onshape as the next generation tool, right? True software as a service tool that you don't have to worry about installing or doing anything yourself with it. And of course, with the virus pandemic, that the work from home and working on any device was something that Onshape really thought that we could help with a lot. So to help there, we thought that we could offer it to the schools in a much easier way in universities, right? So in less than 9 months of setting up this education program, we acquired 1 million users at universities and schools around the world using Onshape today. Okay, so there are many out there. There's still many more to get, but this actually puts us in the position of being able to, just help in a greater way. And of course, all the students are starting to learn Onshape, and this will obviously seed, the market, of course, right? More and more people are going to be asking for Onshape. So, second place already in CAD for education, right? And of course, we have thousands of commercial companies using Onshape as well across all industries and all over the world. So I can see the Q&A panel is a great place to ask the questions. So definitely use that. I'm going to pull that open
So
myself.
we have questions flowing in. The very first question is this software needs high RAM?
No, it does not need high RAM. I'm running on a MacBook computer with, it's a good MacBook, right? 32 gigs of RAM, but it doesn't matter. You can run this on a Chromebook with no hard disk, right? It's no memory, that you can run a small amount of memory, because what's happening is the system is running on Amazon AWS, right? It's not running on your local computer. I'll just open up a very large assembly here just to kind of illustrate the point. So I'm opening up like a robotic work cell here. So it's not sending files to my computer. It's opening this on sophisticated data centers at AWS, and it's sending an instruction to my browser to build a 3D graphic locally using my local graphics card. So the most important thing, if you're working on large assemblies, I would say, is just to have some sort of graphics on your computer, graphics card of some sort, but it does not need to be the special graphics card that you need for a CAD workstation. It can be any, like for video games or something, it'll be fine. So that's really the only thing you have to worry about. Bring a computer that's modern, it has a web browser with a small internet connection, and that's it.
The other question is, can we perform finite element analysis as well?
So yeah, with our app store, that's how you would do that, right? So in our app store, you'd subscribe to the OnScale app. There's several others as well, but OnScale is the most popular one. And you can run the finite element analysis on your Onshape models. You get a certain amount free every month, essentially. So if you do analysis every single day, all the time, you'll end up needing to buy it. By the way the software works, it ends up being like, $5,000 US dollars per year, essentially, if you were to run it all the time. But you can run it like 2 hours a week for free. It's so you can try it out very easily. And like I said, we have a conference tomorrow, and we're announcing our own internal simulation software as well that just runs all the time inside of Onshape without having this app. But this app is going to be better than what we provide. This app is multi-physics. So it's, it'll have fluid mechanics, it'll do stress, mechanical, right? So it's high end, where ours is going to be for the everyday kind of work. Good question, though.
Yeah, another interesting question. Does it work with point clouds?
So we can take data in that's been processed from a point cloud. So there's usually special software for that, right? To, scan something and then turn it into a 3D model in some way. So it takes the point cloud and converts it to a mesh-based object. So we're not the software that takes the point cloud and brings it to a mesh, but we can take the mesh and then bring that into Onshape. So in my pulse oximeter here, I have an example of that right here. So this was an OBJ file that was scanned from a 3D scanner, and the 3D scanner provided the software for doing the point cloud to mesh conversion. And once the mesh was done, we can import the mesh in Onshape. But what you can do with a mesh is obviously going to be limited, right? Because it's not like a proper BREP solid model. Onshape does have some capabilities where you could, obviously use this as a reference, right? So you might create a curve, that fits through, these elements to draw something like that. Or, we have custom features that you can add to your system. So I have this thing called Boolean Plus. So what that would do, if I wanted to, modify, well, that was a wrong plane. Hold on. If I wanted to like put a plane right here using those 3 points and then extrude something, with it, perhaps some kind of metal rod or something. Yeah, I'm going to do that. And that's a separate body we can work with, but we can use this custom tool. We've opened up the Onshape programming language so people can write their own tools. So maybe I need to take this tool and remove it from the mesh. And let's see. It might be because, yeah, that edge is going to be really tough. So let me just transform this over. I'll just slide it over here. Now we'll do our Boolean tool here. Subtract this from that. Oh, let's add. Oh, yeah, it did it. Okay, there we are. So now I've removed that material from the mesh. So we can do things like that. And I think in the future, we'll be adding more to this, but the actual point conversion to the mesh is something that Onshape will not do. You would need, there's special software out there. There's one called Rapid Form. There's several tools out there that specialize in that. But once we get the mesh, we can bring that in.
So the next question is, do you have electromagnetic wave design solutions? Can Onshape design antennas, medical sensors?
We don't have any electromagnetic simulation. You would use something like ANSYS or some other simulation tool. Of course, Onshape can export to any file format, right? So we can, get a step file and use your electromagnetic simulation software, that you currently own.
So what is the recommendation on internet speed?
Good question. Any modern business class internet will suffice. 3 megabits or more. And it's not like, if you have a company of like a large number of people, you don't need like extra internet because of that. Remember, we're not sending files back and forth, and we're not streaming graphics. So it's a very small amount of data that goes back and forth when you're using Onshape. It's really just sending the instructions back and forth, right, onto what to do. So internet speed, you do need internet all the time. You just need to have a basic internet. And if your Wi-Fi goes out, you can use your cell phone hotspot if you wanted. I had a my sales team just to test a little hotspot. We had them log into the same assembly all together on a 3 gigabyte, 3G hotspot. And they were all in that large assembly in 15 seconds, all working together off the same hotspot. So it's a really small amount of data.
So actually we are done with the questions.
Nice. Essentially, the way Onshape is sold, it's software as a service, right? There are different levels of Onshape. If I were going to go to onshape.com, I think I spelled it wrong. There we are. Right. It's very easy to understand. I think, there's these are the commercial levels. There's educational levels of the software as well, which I'll talk about. But essentially, it's the same price all over the world. This is the US dollar price, but you can obviously, buy it in any country in the world, but it's the same price worldwide, essentially. So it's really nice. You don't have to worry about, I have to buy it for one price in one region and one price in another region. It's all the same price worldwide. So what you saw pretty much me do today was everything in Onshape Professional, which is $2,100 US per year per user. So it's a user-based system. It's not like a floating system. So everybody would have an account. You have a standard plan, which is really geared for single users, where professional is geared for companies with that release management workflow. We have an enterprise system that allows you to do, that business analytics and reporting on things. So if I went to my analytics, you would see, maybe a dashboard on what I did in 2019, right? So how many users, how many versions, where people were working, what's released and what's waiting to be released. I could even go down to the user level and understand, how many hours Ed was able to put in on a certain project and bill the project appropriately, right? For my own internal engineering. So that's what the enterprise plan does. That's $3,000 per year. There's also a light user for viewers at $300 per year for the enterprise plan. So it's pretty cost effective when you compare it to what you have to go through with a traditional install-based environment, with setting up your own servers and maintaining your installation and backups. Onshape's taking care of all that for you. There's nothing for you to nothing to worry about, as far as infrastructure goes. So very easy to buy there. On the education side, the student access, there's two ways of buying Onshape for schools and students. There's the education plan for organizations, and that's $3,000 per school. So, pretty much as many students as you want, $3,000 for the entire school. That's the number one plan. And then students can have their own personal subscription as well, which is free. So that's, if you needed more information on that, you can work with the team here on the call.
Thanks, Michael. This is Ashwani, and I would like to add here on the academic perspective. So to all the academicians, we are offering Onshape enterprise plan free of cost for some time, and the Ramses team will get in touch with you to explain how you get benefit out of it and how you can sign up. So we'll share the process with all of you.
That's great.
Excuse me, Michael, this is I just had the questions from outside. Someone asked me, can we utilize the power of the PDM to manage the data for constructions, for example, Revit or other, to convert the PDM as a PIM solution?
Right. Yeah, that's a good question. It comes up sometimes because there really is not a good solution out there right now for cloud full SaaS construction industry stuff. I would say no, because the references and relationships that Revit has is going to be very different than what we understand. Of course, you can store information from Revit in most people would store a neutral file, a SAT file, PDF file, AutoCAD drawing file, something like that in Onshape, and that would do well. But with Revit itself, the way Onshape is built, it's to be the system of record, and you're using Onshape to design things there. But with Revit, they have their own file structure that would be incompatible, with the way we've built things. So I would say the output from Revit, you could certainly manage in Onshape, but Revit natively, I would say no.
Yeah, and to add some points on Revit side in terms of the CAD design, you can use Onshape, but Revit being an architectural software, so they have the library dedicated when we are constructing a building or a mall or a house. So if you'll go to the library, you will find a stored library on the number of design doors or window doors, or how you want to put your roof, what kind of roof you would like to have. So that's more specialized on architecture point of view. But if something on the design part of it, you can use Onshape.
Yeah, we find that often. We have companies that build, air conditioning units and, things that go into a building, mechanical things, right? That's where Onshape would be, a fit. We're really kind of competing in the same arena as SolidWorks, Creo, Inventor, that space where, those types of products are used for mechanical designs, and Revit and AutoCAD are the stars of the show on the architectural side. Maybe someday there'll be a software as a service Revit someday, hopefully, someday. Not from us, but somebody else.
Or maybe smart homes, Michael.
Yes, exactly. Exactly.
Yeah.
Other question is about SolidWorks and comparison with Onshape. Can we give us some kind of comparison in that between these two softwares?
Between which two software? I'm sorry, it cut out for a second.
Yeah, it is between SolidWorks and Onshape.
Oh, right. Well, I worked at SolidWorks for a long time, so I know the differences. There's probably, it's a wash either way. There's going to be a lot of things that SolidWorks doesn't have that Onshape has, and a lot of things that Onshape has, that SolidWorks has right now that we might not have too, because they've been around a lot longer. So, I would say where SolidWorks probably has a small strength is in, a lot of the different apps that make the extended system more integrated. So, all of the simulation tools and the electrical tools and things like that are things that, like piping and wiring, are something that we don't have right now. Okay. We will, and I'm sure it'll be good, but we don't have it right now. So you can certainly draw those things and model them, but you'll probably be more efficient doing it in SolidWorks today. But on the other side, Onshape has, all the basic modeling tools that you would expect, for surfacing, part design, frame weldments, sheet metal. We have excellent sheet metal. But so there are certain things that, that will end up catching up with. So we have updates every 3 weeks to satisfy that. There's a what's new section. So literally every 3 weeks, we have a major update. So like we just introduced bomb views, so you can have different types of bombs. We have this new performance tool, the more call out things. So as time goes by, every 3 weeks, we have these updates. So if there's something that is missing, we can catch up pretty quickly. And we base our improvements based on customer requests. So you can contact support inside of Onshape. So if I was in a design and I had a question, I could say contact support. Can add a screenshot, point to things. We need mesh editing, right? And you could share that document with the Onshape support staff, and they would be able to write a ticket up. And, if a lot of other people are also asking for mesh editing, then it would most likely be added to the software in one of the 3-week design sprints. So that's how we do our development at Onshape. It's not like a big annual release. It's just smaller. Every 3 weeks, you get new functionality. You don't have to do anything to get it, by the way. It's just automatic. There's nothing to install, right? You just sign in and you have it. In fact, you might be in the middle of a design session and your software updates while you're working on something, which is really cool. So I've had it happen during webinars like this. There is a page on the Onshape website that does a very basic overview, though, of what the differences are between SolidWorks and Onshape, and there's various webinars. But really, for the vast majority of users, the tools in Onshape itself are adequate. We have companies like Trek Bicycles, Garrett Turbochargers, NVIDIA, Music Tribe. These are all very large customers of Onshape. These people all have like 100+ licenses of Onshape. So they're not just like trying it out. Like Trek threw away SolidWorks in favor of Onshape. And Garrett threw away CATIA. They had 1,000 users of CATIA. And they all use Onshape now for doing turbocharger development in the automotive industry. Music Tribe is based in Asia. And they, threw away 100 seats of SolidWorks in favor of true software as a service cloud-based design. So, there's real life companies that have standardized, and very important companies that have standardized on Onshape. So it does have the tools to get your job done. It might just do it a little differently. We do have a learning center built in to Onshape, so you can do self-paced courses. There's technical briefings and videos, and we even have live instructor-led training that we run over the web, of course, that you can purchase. And these courses are actually run by instructors that all have SolidWorks experience, because 85% of the people we talk to are all former SolidWorks customers. It's just the way it ends up shaking out with Onshape. So, we try to have good relations there.
So there is a question. So does it support additive manufacturing?
Well, we can certainly export to additive manufacturing, STL and OBJ and stuff like that for 3D printing. Almost all the 3D printing and additive manufacturers use Onshape now, and like Formlabs is, standardized on Onshape. They've thrown away SolidWorks, so they've standardized on it. But as far as like special applications and tools that do lattice optimization and topology stuff, we do not have that right now. So you would use a special application. Usually the 3D printing company themselves provides software to help with that. I know Autodesk has some very interesting technology on lattice optimization. I know Creo has very, very good stuff there as well. Perhaps we'll get that in Onshape by being part of PTC, right? So that's all on our roadmap, but not today, I would say.
I think there is an app also in App Store for additive manufacturing.
There is. I haven't used it in a long time, so I didn't mention it because of that. So there is, if you go to the App Store, if you go to additive here, some of these are private. Yeah, here we are. So 3D Printer OS is probably the only one that's public right now. This one's new. I haven't even seen this one yet. Quick 3D printing, 3D models. Thank you for that. I would never have noticed this until today. Thank you. Yeah, so they're always adding new apps. I need to check this one out to comment more on it. But it looks like a way of managing your 3D printing operations, almost like an ERP system for 3D printing, which is interesting. I'll have to check this out some more. But there are STL. That one's private too. Yeah, I remember we used to have a couple of them, but they're still private. So some of these apps are not released yet. When I sign in, I can see them, but the general community cannot. But the App Store, you can browse this yourself without an Onshape account. Just go to appstore.onshape.com, and you can see all the different apps here and explore what the possibilities are. These are all great questions. I see a question here. Is it suitable for beginner students? And I would say yes. We have students that are, all the way down to the lower elementary schools to the universities using Onshape. So, it's not like a toy software, or like, it's still professional software, but they're still able to kind of, learn using Onshape. And we have, robotics teams using Onshape. There's the robotic design competitions. The first competition, that's a very popular competition that students use, in the CAD modeling world to build their robots, and many of them are using Onshape now. So it's fairly easy to pick up and learn. And I think by this time next year, Onshape will be the #1 application for mechanical design across the world for education and academic and higher education and lower education.
I can see one question on academic education version. Mr. Ibrahim have asked. So is it related to just the general, what is there in education, or do you have any specific question in terms of number of users or the capability wise? Mr. Ibrahim, I've seen your question, so. So I couldn't get any question regarding the overview, but let me explain it, how it works in academic institutes. So in academic enterprise pack, we have all the capabilities which are there in Onshape Enterprise as a commercial point of view. In academic pack, we'll have 500 users for the institute. And for the pricing part, you can talk to Mr. Rayad from Ramses, so he can get back to you. And we will be coming up with an offer for during this COVID for some duration. So we'll get in touch with you through your email. If you have any other dedicated question on academic institutes or academic version, I'll be happy to answer that.
There's another question I see on, I don't have a good image of it just right now, but an app for sculpting. We do have an app in our App Store that's going live very shortly for sculpting. It'll be an app in our App Store. So if this type of surfacing is not, the right way you like to do it, you prefer more of a sculpting method, there will be an app called Phi, P-H-I, in the App Store very shortly that allows for that. I would expect that to be available to the public soon. I've been playing with it a little bit. It's very nice.
Also, I can see in the chat box there is the Dr. Naeem Farouk asking what is the accuracy of the results. Is it used for all level of students, undergraduate and postgraduate, or graduate student, for building and analyze the systems?
Oh, right. So for simulation results, that's something that you could, check into with the OnScale people. Onshape isn't providing the simulation currently. So, they have reporting on the validity of their, analysis and the accuracy, but it's similar to what, most people are used to with, other finite element systems. Onshape runs on a Parasolid kernel for the CAD modeling itself, which is the same as SolidWorks. So that accuracy for the CAD modeling is exactly the same as SolidWorks. And that's right in the on scales for FEA. So you can look up some validation examples if you know, we can hook you up if you need those, you know, we can help there if you need some more information on that.
Okay, thank you very much, Mr. Michael, for this wonderful time and presentation for Saudi engineers. And any other questions? If anyone wants to ask more questions, he can pop up and send us our email or on Twitter, and we will reach him soon. And this session is recorded, and we will publish the recording in our portal, YouTube and Twitter. And thank you very much for your time.
Thank you. Bye-bye now.
Goodbye. Thank you.
Thank you everyone for joining. Have a nice day. I will end the session now.